All right, so this one's going to be pretty short. And so let's see. It's been kind of like a mental map that I have been going through in order to understand like how to build like agentic applications. So my first question is, how many of you know what a typed runtime actually is? Awesome. So not many people. So as search was showing, like everything is typed in effect, right? So we got like types for everything, type for error, dependency, and the actual value. So that's the effect type. But also effect allows you to do a lot of like runtime typing. So runtime means like whenever the user is using it, somehow we're able to identify what function they're using or log it or so on. So we're able to actually type through what the user is going through, right? So that's what like a runtime typed application is, and this turns out to be extremely important if you want to be able to sort of like build agentic or AI native applications. Let me see. So one question that I want to ask really fast, like what does agentic or AI native means? Like, and I really want you to just give me like some answers of like whatever like conceptualized. And I know you've probably been bothered with these questions all over the place, but they're very, very interesting questions because that's how we actually can determine how do we architect them, right? Like, so the purpose of software in general is that we have some sort of representation of what we do, and we're able to sort of like switch things without like breaking the entire thing, right? So we got a very complex model, and with that model, we're able to say like, well, I want to change the model, or I want to add a tool, or I want to do something else, and I can do it without actually breaking the entire system, right? So if, does anybody have like some mental, so go ahead, sir.
Yeah, I will this help. Something that can sense its medium and act.
Something that
can sense its medium, like
something that can sense its medium.
sees what's happening around it and also can act on its medium.
Awesome, awesome. Any other takes on agentic or AI native? Okay, cool. So, for example, let's think like really quick. So what, like if we would have to design like an emergency response system, right? Like and we, you know, I don't know, 911 calls us and tells us like design the new system for immediate response. Like, you know, you're gonna receive calls, you're going to forward them, we're going to check the streets, whether like we can go through paths, we're gonna send helicopters, everything is gonna be agentic. So obviously that application cannot break, right? So how do we actually structure that application agentically or with LLMs so that we can actually create some valuable software without it breaking whenever we change a model or whenever we add a tool or things like that. Or also, like for example, like another question is like how many agents? So should it be one agent? Should it be 20? Right? In general, like we talk about capabilities, right? And we want to isolate capabilities so that we can actually evaluate them and build upon them, right? So I'll talk a little bit about Effect and what it does. So Effect has a package called Effect AI, and I think it's still a lot of it is in 4 and it's unstable, but you know, I mean it's typed, so feels pretty good. So every time you call that model, you get like you get a runtime, you get a series of events that could happen, right? And that is actually it is actually timed. So you get a response that's stream part. So pretty much what that means is you have a model, and the model emits different events. So the model might say agent. So for example, when it's sending text or streaming text, it will have like a text event. When it's thinking, it might have like a thinking start, thinking delta, thinking finish. So let me show you really quick. So pretty much like these are all kind of like events that can happen when you make just like a single agent call, right? So you have text, you have reasoning, it can call tools, and it can do a lot of other stuff, right? But like we haven't typed, right? So that's pretty good because what happens is every time they appear, we can either check the logs and we can know exactly which one was doing it. And then if you connect it with schema, which each one is a schema, you can actually use bidirectionality, connect it, and do whatever you want with it. So gives you a way of like evolving your system. I'll go back a little bit. So In effect, you can declare tools, right? So, and the tools also have input and output, which are also like structured with types, and that's what like later creates it adapts. So if you see how like effect passes it, so now you get like all of these parts and so on, right? So pretty interesting, but in general, maybe not too useful. But there is this agent made by a guy called Tim Smart, which is in the core effect team, that is called Clank. And Clank is just like it's kind of like a POC of a coding agent. It's fully built on effect. But the reason why I want to bring it up is because what Clank does, and I really suggest you looking at it because it's really interesting, because it gives you like a purely typed and then purely runtime typed agent structure. So pretty much what you go from what I showed you before, that we had like these text, reasoning, toolparts, sources, finish errors, then it uses those events to build further events. So instead of like printing those events out, it says like, well, I'm going to make agent output events, and I'm going to say like start, reasoning, calling scripts, usage, retries, sub-agents, and so on, right? So pretty much what Tim did on that, on Clanka, is take those events, use effect on top of it, and then build his own language of events, or typed runtime events, right? So as I said, like, here's the list of all the events that come out of the agent. So something that Serge was saying, so I'm not gonna show you the effect type, but this is a pretty similar, right? So what happens every time you call the agent model? It runs once, right? So let's say you send a string to your model in the chat box, and it will give you an effect. So the return time is in an effect. The value that you expect is a stream, and the stream has agent output, right? So agent output, remember, is the set of all of the possible events that can happen, right? And then, as Serge was showing you, we have some dependencies. We need scope, we need the language model, we need the provider model, and so on, right? But these are all the service requirements, right? But the beauty of this is that, like, here you have the entire agent, right? Like, this explains you the entire thing, right? It tells me that this agent can only sell me agent output. So as long as I'm able to handle anything that happens in agent output, my agent will always work. Like, it will never crash. And it's not just that, but you control the runtime, and then pretty much you can put your agent autonomous. So let's see. That's pretty much what I was trying to tell you. So that gives you ability to inspect, control, connect, and so on, right? So my point is, okay, so here we saw how we went from model and model events to agent events. So what is the next sort of like logical step? Well, what if I want to architect applications with as agents as first class, right? So maybe I want to say, how can I make agent coordination? How can I make agents talk? Because, like I said before, if you have like an emergency response, I might want to divide different agents to have different operations, and I still want this whole thing to be typed. So let's see. So I found a paper, pretty interesting, by a guy called William Waits, where he talks about agent coordination and organizations, right? And this is more of a theoretical paper, but what they come up with is with a calculus or with a category that is able to sort of operate over the streamed events. So pretty much what A means is like a stream channel carrying A values, which is like a stream of A in effect. We have functions from stream A to stream B. We have composition, we have product, and these are simple things. Composition means like I have an event and I have another event, then I connect them. Product is just like a pair. And then some operations like copy merge. Copy, if you think of it in streams, or merge in streams, is like stream.merge. Barrier, pretty much the same thing. So what is fan out, right? So like, if you copy, you're fanning out. So pretty much what you want is you have a stream of certain event, and you want to send it, say, to 2 different agents, so you have to copy or broadcast them, right, like in streams. Merge, and then you have barriers, map, filter, which are the same thing. So that's actually what I was going to show you on the front. So pretty much I ported a little bit of the functionality of that paper or that library. And what it says is, okay, so we're going to represent a stream of A's as schema. We're going to represent a process, which will be a node, as a program that has input, output, error, and requirements. And then these are just like stream operations. So for example, what is it that we can do if you do something like that? So imagine we want to have a critique, right? We want to critique drafts. So a user makes a draft. We have 2 reviewers. We have a clarity reviewer and we have an audience reviewer. They're both typed. They go into a bundle and then there's an editorial decision, right? So it's just a simple, very, very simple example. So we're able to declare all the schemas of every single step. So I have a draft, I have a clear review, review bundle, and so on and so forth, right? And then this is just like a way of saying, so plumbing is the name of the library. This is a way of saying, okay, I have a way of putting inputs. So the input is of type draft. I can create an agent that takes this input and then it has an output, which is the review, right? And then the prompt has some functionality. Actually, this is not complete, so somehow the agent wasn't helping me here, but let me show you the full code. So in here I have like exactly what I like, just like one workflow per se, right? So it has all the types. These are just like helpers for the web app, so not a big deal. But then the nice thing is that for each agent or for each component, I can actually run it deterministically. So I can have for each one, since it's a service, I can have a layer for it, and then the layer can be just something that I return pretty much to know if the entire graph or the entire architecture compiles. So this would be some sort of like deterministic layer, right, for like say the editorial node, and this will be some layer that actually uses an agent. So pretty much we can just, you know, I just have a function for each one of those operations that I told you, so I can either barrier, meaning like I can merge like multiple results of like different events into one agent, or into like say wait and then an agent consumes it. I can fan out, I can put, I can map, I can filter, and so on, right? So those are just basic applications. So let me show you a little bit of how this actually works. So for example here, let's see that. So this is like this is the complex. So this is kind of like the editorial review. So what I can do is I can have it deterministic and I can run it, right? So this already tells me like, okay, so if you give me fake data, your thing compiles. So I actually already know that it won't fail with agents. So if I put it live and I run it, so this one pretty much had that. So this one become active because they're actually running, technically, if this works. So this one's completed, so this one will send it here. The audience reviewer now completes, it goes to here. This is the barrier, this is the one that says like, what do I do with these two? So I make some sort of operation with them, and then I have an editorial restriction. And the details don't matter, but pretty much this gives me like what the decision was for each one of the drafts. So in the input, I send it like say to draft, and then it says like whether I reject it or accept it, right? So I made a more complex, and I actually just like vibe coded this because like so pretty much I made a skill that takes this plumbing library, and pretty much it can make you any deterministic sort of like workflow or loop to work directly. So you just tell it like, hey, I want this, this, and that. Talk a little bit about the schemas, and you got it. So let's see so deterministically we run it. So this is with like the sort of fake data, and you can see like everything becomes complete because obviously it's not really running any agents. And then this actually contains even like loops before, so it has some sort of conditions that the agent might not satisfy, so it goes back to the previous node and tries it again. But anyways, so what is the advantage of this? So now I have a full, this is a POC anyways, like I'm not trying to claim that this is something big, but I have a full architecture, agentic architecture, where while each agent is non-deterministic, the wrapping around this and the schemas of the inputs are, I can loop through them, I can make any type of graphic around it. And for example, let's say if you got like a Git process, or you got a company, or you got whatever, workflow or architecture you have, and I don't like the word workflow because this is more like agentic architecture, I would say, but it will pretty much compile to something deterministic. It's not like, because this comes from like sort of like the frustration. I don't know if you experience it, like if you're like coding with your agent, at the beginning you start and everything is wonderful and like the structure looks cool and like everything's working out, but all of a sudden you're like, okay, where I am, like, did I say this? No, I want something here, no, I want something there. I need to change the agents.md and put something else. And with something like this, like you can actually, have a deterministic structure for what you want to do. But that's not really all of it. Like the thing is, like, since all of this is compiled, like it's typed, and it's also using schema before and bidirectionality, I have a full trace of it, which means that if in the future I need to add another node, I can actually give an LLM, okay, how can you optimize me so that I can add another node so that you still don't break me like the entire structure, right? So that's pretty much it. I don't know, I've been working on this for like a couple weeks and it's really good. So I'm gonna try to take it out a little bit farther and do like some of those like sort of like evolution and optimization and so on. And that's kind of like the idea behind it. I think that's it.